Okay, so now that we've learned how to add and subtract both unsigned and signed numbers, and we talked about how to determine if the result was valid or not in all those cases, let's figure out how we can design a validity checker. So right now we're going to do a validity checker for signed arithmetic. Okay, so let's say we have two 4-bit numbers, A and B, and we put them through an adder. This was RCA here, and we're going to get a 4-bit sum output. How do we know if this sum is a valid sum? Well, we can create another module which we can call isValid, and we'll have an output of valid and an input of AB, and I guess we'll call it S. And what we're going to do is we're going to take the most significant bit, or A sub 3 in this case, and connect it to our A input. We're going to take the most significant bit of B and connect it to our B input, and take the most significant bit of the sum, let's see, sum sub 3, and connect it to our S input, because what we're doing is the most significant bit of any of these is the sign bit. So we can see if we have two positive numbers and it outputs a negative number, we know that we have a problem. So let's see how this is going to look. Alright, so we've got 3 inputs. We know we're going to have 8 possible combinations, so I'm going to put our ABS here in the truth table, fill out all possible combinations, 0, 1, 2, 3, 4, 5, 6, 7, and our output valid. When are we going to have a valid result? Well, if we have 2 positive numbers here and here, and we get a positive number, yes, that is valid. 2 positive numbers and get a negative number? Nope, not valid. How about a positive number and a negative number? Yep, anytime you have a positive and a negative, you're going to get a valid. Positive, negative, getting a valid. Negative, positive, going to get a valid. Negative, positive, going to get a valid. And 2 negatives and we get a positive. No, not valid. 2 negatives and get a negative. Yes, valid. So we can figure out what this is in a K-map again. So we've got our A, B, and this is our C or S in this case. And our invalid is at the 1 position and at the 6th position, 4, 5, 6. So our 1s are here. So now we could say valid is equal to, well, we got this grouping, which is B naught, S naught, or this grouping, which is AS, or this grouping, which is B A naught. So there you go. We've just created a circuit that will tell us if our result is valid or not for the signed arithmetic.